Okay, so today we'll take a look on 4Sum. So ideally there is a prerequisite. So if you need to understand 4Sum, ideally first do 3Sum, right? It might sound very bad, but can't do anything. It's named like this. Yeah. Now what we have given here is we have given an array, and ideally we have to figure out a quadruplet that can give us this target that has been given to us, right? So let's take an example of this, and I'll directly go through. Ideally we can go and do the brute force optimal, right? But again, the approach here is to get to the best one just directly and get it done quickly. So in 3Sum what we used to do is, let me get the pencil. We used to sort it first. So when we sort it, we will go to get something like 0 0. Okay, there is a -2, -1, 1 and 2. Okay, and what is the target here? Input to the target is 0. Target is 0. So ideally what we used to do here is we used to have 3 pointers I, J, K. We used to fix I, right? Suppose I is fixed here, then we used to fix J and K here, and then we used to travel this side and this side and get the sum, right? And get the sum of I plus J plus K, and if it is becoming like target, then that was part of our solution. And if there is a duplicate, so if there was a duplicates, then we used to skip that, right? If you know 3Sum, it will be very easy. Just the point here is now we need 4 numbers, right? So we need I, J, K and L. And what we will do here is we will fix I first. We will fix, let me add some space here. We will fix I first, and then we'll fix J first, and then we will put a while on K and L, and we will travel from this and this, right? And then in all these 4 pivots, we will try to ignore or skip the duplicates. Now I'll go to the code, we'll do it here and we'll see how we can do it. So as I told, first of all, let's take the length. Okay, and we also need an array to save the answer. So we have these 2 with us now. Now we will say, okay, we need to sort it, right? That was another requirement. So nums dot sort. If you don't know why we were sorting, then 3Sum video from anywhere will help you. Ideally the sorting reason behind is because when we want the sum greater, so we know that suppose we have like 1 2 3, right? And like 0 -1, like this some number is there, and we are till here, right? We're till here, the sum is -1, and we want to increase the sum, right? So to increase this, every time we have to include the next element, then it will become like -1 plus 1, that is 0. Then again we want to increase, then we have to move this side. Same way, if you want to decrease the sum, we have to move opposite side, right? So that is why it has to be sorted. If it is not sorted, then elements can be anywhere, right? But if it is sorted, then we know to increase the sum we have to move this way, and to decrease the sum we have to move this way. Okay, going back to the screen, now we will sort it. AB A minus B. Now it is sorted. We'll start the loop for let I equal to 0, I is less than n, and I plus plus. So we have this I set here, and what we will do is we'll try to ignore the duplicates in I, right? So suppose there is 2 0 zeros, right? So we cannot take it again, as this is required. A, B, C, D are distinct. So what we can do here is we can say if I is first of all greater than 0 and nums of I minus 1 equal to nums of I. So what we are doing here is, ideally this is what we want to do. We want to check whether the last element, the previous element, is same as current element, and to be for this to run, we actually need a previous element. So I should be greater than 0, right? It cannot be, if it is 0, then there is no previous element, and it will fail here at this line. So, and if I is 0, then ideally there is no need, correct, for this continue to happen, because that is the first element and the first element is distinct. Now next thing what we will do here is we need the J loop for let j equal to I plus 1. So next we're starting from the next one, so I is selected. At this point, if we come to this point, I is selected. Now let's select j. So we will choose j from next one, because I and j cannot be same, right? It has to be distinct. J plus 1, j is less than n, and j plus plus. Same way we'll do here. We'll again copy paste this line, and we'll say if j is greater than I plus 1, right? Because the first element of j is I plus 1, it will be I plus 1 in every loop. And then we will say this. So kind of same logic. So now we have removed the duplicate from I and j, and then we will need k. K will be nothing but j plus 1, and last will be L. L will be n minus 1. So now we have all the 4 positions. Now what we want to do is we want to check if the sum, right? So we'll say, let's say const sum equal to nums of I plus nums of j plus nums of k plus nums of L. Okay, and if this video is very fast for you, ideally this video is not meant for anyone to go and learn. It is simply for me to revise things and keep it in some place. And yeah, if it is understandable, then it is fine. But this is not an in detail video. In detail video you can go and search in YouTube anywhere. It is basically they will go to the brute, better and optimal, and this is just for a revise part. So okay, yeah, we have the sum. We will check if sum equal to target, right? If sum is equal to target, then we have our answer. So answer dot push, and we will again push here nums of, we need to push an array. So nums of I, nums of j, nums of k, and nums of L. Okay, and then so once we have all this thing, what we want to do here is we want to do k plus plus, and we want to do L minus minus. But again, the point is, what if the next k and the next L is again the same number? That is the reason we have to check while we have k is less than L. So suppose it happens that you keep increasing k and decreasing L, and k has crossed L, right? So that means we have scanned all the elements, so there is no need to go there. So that is the reason we have kept this condition here, that k should always be less than L, and nums of k minus 1 equal to nums of k. We can do this k minus 1 here because we have already incremented k by 1, so we know that there is a previous element. If that is the case, then k plus plus. That means if there is a duplicate, then simply keep moving until there is no duplicate. I mean simply like same element. Same way we can do nums of L and L plus 1, because L we have moved from right to left, right? And then we have to do L minus minus. So in this way we have removed the duplicate element issue in KL and J here and then I here. So what if the sum is not equal to target? Else, okay, else if sum is less than target, right? The sum is less than target, right? So what we have to do is we have to increase the sum. To increase the sum, what we were doing is we have to move from this side to this side. That is, we have to increase k. So we will say k plus plus, and then again if sum is greater, then we have to do a L minus minus. And once everything is done, let's go here and return our answer, which is this one. I'll just format it and let me run it. Okay, so we have one issue here, and that is this thing. Okay, we are getting wrong answer somewhere. What is the wrong answer? Okay, so let's see what we have done wrong. For let I 0, I is less than I plus plus, I is greater than, and I nums this continue. Okay, j should start from I plus 1 and j is less than n, j plus plus if j is greater than I plus 1. Okay, this looks fine. J plus 1, k minus, nums, sums target, and k plus plus here, l minus minus here. Okay, so ideally these things can happen, and the best way is to debug it a little bit, and ideally it helps to the conversation building, right? So they know about your debugging skills, what is gone bad. So what I usually do is I simply go line by line execution. Okay, so we have got the length, we have our answer, we have our answer. uh, Now we have this sum here, kl sum target. Okay, okay, so the point is I have never made that while loop, right? So what we can do here is while k is less than l, right? So k should be less than l, and then this whole thing, this, right? So this actually was the logic, that we were increasing k and l inside this loop, right? So this was a mistake. Let's run it. Submit. Okay, thank you.